Hello, this is Programming Channel. We have audio insulation foam for better quality of recording. Welcome. Okay, fake Russian is not my strong suit. Programming is more of a strong suit. This is part 2 of the image recognition effort. I've been thinking a lot about it in the meantime. We will try to use one single prototype image, this one here. We are recognizing the cube now instead of Vector's home station, because then I can have him sit on the home station, which simplifies the logistics. Also, the image stream is now in Java. I can save an image at any time, and I can do live recognition. My guess with 3 FPS or more was accurate. It actually is 3 to 4 FPS. So, one prototype image. Challenge. And of course, no neural networks, because those are for beginners. We do our own stuff. This recognizer has gone through multiple refactorings already. So, still looking for the right architecture, because as I said before, we have 4 problems: size, position, distortion, rotation also if you want. Yeah, I see it as part of the distortion. And the last one is lighting, which we will keep constant for now, more or less. It's always a bit differently lit when you move it around, logically. So we have 4 to 5 simultaneous problems, no problem. In the recent experiments, one thing that got improved a lot is the speed. Here I'm doing 2 granularity levels. This is the image in 1 pixel. Okay, where's the home station? 2 pixels, 4 pixels, 8 pixels, still difficult, and 16 is the first resolution where you can actually see blurry things. And in fact, this is the one I have the recognizer operate on, and it came up with these 2 candidates. Actually, the left one is the cube and the right one is the home station, so these candidates are very good. If you make it generate more candidates, it will choose random other areas. So 2 is a good number here, and then we jump from width 16 all the way to 128, where we can do the actual recognition, which we consider decisive, because now we didn't have enough details. And it took the candidates we made here, rather here, this one here, and checked it further and came up with this result. So it saved a lot of time by not scanning the whole image on the high resolution. It just scans one small area around this candidate. And the total time of recognition here is, oh, it was here, 8 milliseconds. That's fast, but we will have to do a little more work to account for distortion. Yeah, mainly distortion. We will have multiple of these prototype images, just showing the object from different perspectives. And then we check all of these against this area. So the effort multiplies, but if we keep the search area small, it can still be doable. It checked 500 different positions in this resolution. 500 is quite a lot, it's probably excessive. I made the search area a little bigger, to be sure. So yeah, at first the results read 1 or 2 milliseconds. I was really happy. And then I found out it was a bug. It didn't really do the whole recognition again. So now we're at 8 to 10 milliseconds. Let's run it again. It runs it 1000 times to let Java optimize. It's already optimized now. Oh, it's gotten a little slower for whatever reason. More background load on the machine. 16 milliseconds, 13. I have high goals for the speed of this recognition. Because if it's fast, it means we can run it on small machines, for example. All right. So these two levels are, I think, a good first approach. I basically want to restructure the recognition framework. What does the pros say? Refactor is what they say. Refactor recognition engine. Yeah, it's not even clear which one to start with. I have multiple versions already. And this is, you know, it's ambitious. I want to solve the whole problem of recognizing typical things like this one here. So in one go, we have to kind of solve it. Solve the 4 to 5 problems, which I mentioned earlier. Let's just make a new module or class, actually. Yeah, this is going to be a lot of thinking and stuff. This is a thought-oriented stream. I still think I could make cuts of this for YouTube. Skip the thinking and coding and just show the results. It's a good idea, but it's always some work. I am my own editor and everything, so I have to manage my time until the team grows. I do think that this thing I make right now is really important. Maybe it's going to work even better than I expected. And if it does, we have a new image recognition algorithm that might change the world, actually. So we just have to get it going. How about cheesy recognition recognizer? Cheaty, cheapo image recognition by scanning for prototype images. The basic thing is that it actually just scans an image for another image, pixel by pixel. But it does this in optimized ways, so it ends up being quite powerful. We'll see. In this new architecture, we should have actual classes for everything. Makes it more readable, more flexible. Class prototype, that's the prototype image. And it needs to have an integral image. Boom, that might be also already what we need there. Then we have the scaled version of the prototype, which then is just a normal image. And we want to note where it was scaled from, what it was scaled from. And we want to record these in lists. A list of prototypes and a map of scaled prototypes. And this is width. I did scale these by height, but let's stick with width, I guess. Makes it more consistent. Okay. Don't you love funny names? Cheesy recognizer. Aha. 7278. Have some humor. Humor usually improves everything. Okay. Okay, first we need to initialize it some way, obviously. Input image. The input image should also be stored. But we will store it as this one here, I think. Oops. We will also need scaled base images. Scaled input images. So input image is a bit long, but I couldn't really come up with something better as of this moment. Okay. Oh, what, 2 typos in a single word? My. Yep, that looks good. Hey, let's have Vector say something. It is sleeping right now, so will it wake up? Yes, it will. I turn it to low volume. I don't want the noises to disturb the video. Okay. Minor bugs. All these little functions, the AI could make them for us if it were a tiny bit more advanced. I made 2 cool things, the image recognition and a text logic engine that can think about anything you can describe in words. So I could describe to this engine how to make little variations of existing functions. And it can do this. It's completely possible. AI assisted coding. But I only have 2 hands and 2 brain hemispheres and 24 hours in a day and so on and so forth. So it compiles again. Aha. I can have vectors say or play any audio file too. Yeah, volume was low. Probably didn't hear anything. But Vector is very flexible. It's very cool. Really cool. So let's get the latest image and make a recognizer on it. I don't have a function yet to get the latest image, but we can add it to this VectorCam module. API get latest vector image, or whatever works. Actually just get image. And we register ourselves. We already did. This module is registered as vector camp string. Hey Vector, what's the weather? 13 degrees, getting warmer. Still very cloudy. Okay, get latest vector image. DM call, some service, and some method. Yep. Yeah, once again a case for AI assisted coding. Makes this little fairly uninteresting convenience method. Yeah, but this doesn't work. This works. Or can you? Can you call functions before you call the... Wait. You can. It's a bit of a quirk in Java. You can actually call functions or constructors before you call this main class constructor. But you can't put any code lines up here. If there was some code here, that's rejected. But if you want put the code you want to run in an expression, it accepts it. It's not terribly logical. Whatever. Probably nobody understood what I just said. Okay. Yay, we made a recognizer. And it should store the best results. Or maybe not even that. Maybe we just make some functions that do some recognition. One function we want is a full scan at some resolution. Full scan. We scan for a scaled prototype. Yeah, with these extra classes, the code turns much more elegant. Full scan. And we either want to get one result or a number of results. The coolest thing would be to have a function here that takes all the found images on found. Yep. And this we have pretty much done before. Let's see. Search. No? Try candidate here. Okay. Let's see, pair. Yeah, no, let's put it somewhere else. Pair. Single check. How about proto? Save a few characters. Compare prototype to image at some location. Oh, is Vector gonna move around? Ah. Yeah, this is and let's put that in there. And let's just use doubles everywhere. I'm sick of float. Float is the half precision floating point number. Let's do full precision now, I think. I'm still not sure. I mean, it takes twice the space. Maybe not, actually. Stick to float here in these inner loops. Image. Yeah. This means that nothing was, yeah, that the threshold of error was exceeded. Okay. Ooh. Well, let's see. Let's see. Yeah, here we can definitely go to double. Although, yeah, like this, that sounds good. Looks good, whatever. Almost there. Yep. Let's see if the input image actually arrives. Actually, I believe show image should work. Yep, there's our snapshot. Alrighty. So here, we want the same function, but we wanted to call, to use a callback here. Unfound get do we convert? I think we do convert from error to similarity. Yeah. Yeah. If we found the perfect match, we stop the search, but it's an optimization that we don't always want. One minus, I hope I'm doing the right thing. Similarity. Yeah, let's just try. Min similarity is the actual precise description. Okay. Fail, fail, fail. Yep. Mein Vector is sleeping. He's often tired, like a little baby. Isn't he like a toddler? It's just that's what Vector is. A toddler in robot form. Proto.type, yeah. Classic slip up. That's just this, right? Oh, min similarity. All right. Now we need a helper function that gives us these scaled prototypes. Scaled prototype width map get or create scaled prototypes width and scaled prototype. Okay. We need this one too. Yeah, either we put the pair here or we put the map in this one. Yeah, it's just so many ways. I mean, maybe we put it here. That's quite elegant. And then this function also moves up here. This goes away. This and scale. Yeah, let's see. Scale down using integral image. Image and width. Alrighty. And similarly, we need to scale the input image. I thought I did this. Hey, Vector. Hey, Vector. Oh. He has these tired eyes when you wake him up. Ah. Now he's happy. What's the problem here? Blah, blah, blah. Map, get, or create. Map, key, function. Map, get, or create. Oh, come on. Here, that's the one. A map, a key, and a function. A map, a key, and a function. Huh? Yeah, those are the moments. Just looking for some ridiculous little misunderstanding between me and the compiler. But it is a functional interface. What are you doing? Map, get, or create. I am confused here. Map, get, or create. I just checked this. It's in there. Oh, this is insane. Stop wasting my time, compiler. Let's try and cast this explicitly. There. Oh, okay. Compiler was kind of right, but not very helpful in the message. Or maybe I overlooked the... No, it was only one error and it was not very helpful. Okay, scaling down the input image. Scaled input image. Ah, caught the typo just in time. Yep. I think that was that. Almost. Maestro at work. If I may say so myself. Oh, it's hidden behind all this stuff here. Scaled input image, let's try that one. Dot image. Null pointer exception. Apparently the map is null. How did that happen? Like this, it happened. Here, that's our scaled down version. Very good. Next step. Oh yeah, the question is if we want one or more candidates. All candidates. Yeah. Now we should make a separate function for that. All candidates. Okay. Okay. Now we do a full scan to a data structure. Full scan to best candidates to n best candidates. Yep. Here we get the, yeah, okay. Yeah, okay. Take, no. Here. Okay, full scan. Pass on the parameters. I can't comment right now. I'm just concentrated. Coding. Now we have all the candidates in pairs. We sort by score. Here, sort by second of pairs in place. What? We want the descending version, though, which we can achieve by simply swapping the parameters there. Okay. Red, and now we just take the first, I say first, I type last. That's very smart. We take the first n candidates. Yep. Simple typo. Aha. So, full scan to n best candidates. Yeah, how about just n best? Full scan to n best. We need a scaled input image. We need to put in the prototype, in fact. Add prototype. Add prototype. Load black and white image with ID this. And we save this. Proto get pro scale prototype. And we scale to oh, it's not even this image. We're working on these images here. Let's say 1/6 of the image width. I don't know. And we need a minimum similarity, and we say how many candidates we want. Chessy recognizer. Oh, not bad. I did write a chessboard recognizer at some point. It actually works. You can download it. Recognizes chessboards on screen. The schematic view, not a 3D board or a photograph. Just these 2D representations. But it's pretty reliable. Okay, we have some candidates. Question is if they make any sense at all. We should show them, right? This we can close. Scale from here. Scale to input image. It's quite elegant. I could use the new var keyword in Java, which saves me from typing all these types. But I think I'm using an older Java source level. I'm using source level 1.8, and it came later. var keyword in Java. Excuse me. Java 10. So if I switch to Java 10, I could do this. It's worth a shot. I still support Android, and Android is Java 1.7 plus. It's actually 1.8 more or less. Yeah, let me think about it. I like to support Java 8 for end users, because that's the lowest common denominator. You can be sure that Java 8 is installed if someone has Java at all, which is kind of common anyway. But newer than version 8, you can't guarantee that. Okay, we take only the rectangles, not the scores. And scale to image. We scale to the original image. Let's see. No, these numbers are too small. Let me guess, I put it the wrong way around. Yes, I did. We're trying to find the cube up here, which is partially obscured, and we don't really do that yet. We don't really scan outside of the image. So it might find this one down here, or it may just find it anyway. Let's see what happens. Or it finds nothing, who knows. Okay, there we have our candidates. Candidates. And yeah, show the image with the selections. Hey Vector. Hey Vector. Okay, that was not very good. We should not really use the live image. I mean, we should work on some static image. So that's an easier target. That's what the heck is happening there. Cube. Okay. That's good. Except for the stupid look on my face. So we now use the canned image instead of the live image. Ain't that a lot better? 5 candidates and they are all the thing we want. We should have a pluggable recognizer that takes this live image and, oh, hold on, what if we, hey Vector, hey Vector, hey Vector. I'll let him go to sleep again, but hopefully with a better picture of the cube. Yeah, I want it even closer. Hey Vector, go to sleep. Now let's try the live image again. Yeah, that's good enough. Maybe one more. Hey Vector, hey Vector, go to sleep. He's probably thinking, what the heck is my human doing? Waking me up and sending me to sleep. Yeah. Yeah, it's still because it's cut up. No, I mean, no, the size is too small. We don't have differing sizes yet. If the object is bigger or smaller in the image, we'll have to add that too. Okay. I guess if we took only... Now it has to produce 5 candidates, however bad they are. If we take only 3 candidates, what do we get? Yeah, we get something in the correct area. All right. Okay. We did scan on the high resolution though. We scanned on 128, which will be slow. So we'll do it in a lower resolution first. $128, but it was the before the optimization. It really doesn't tell us anything. Or not much anyway. Doesn't matter, let's continue. We could have this as a function in the recognizer. It's one way of using it. Just scan one big image. Full scan. Also, we can use this in the multi-step process. Yeah, full scan to and best. Here we just take the width. Image width, proto width. This is always something I don't know about. What is the minimum similarity we're looking for? Not sure about that one at all. Int n. Okay. Let's try it. Oh yeah, which prototype are we looking for? We do need that one. Okay. It says 100 problems, but there's only one problem, which is a superfluous bracket. Yeah. Do we add the scores here? Yeah, let's return. Or no? Yeah, let's screw the scores. Just. Yeah. What am I doing? Nonsense is what I'm doing. Ah, the prototype. Hey. Yep. So now what if we do the same thing with a smaller resolution? Let's say 16. Let's check that out. It works. It's obviously coarse, but it has to be because 16 pixels are not that much. This is obviously, this is the pixel size we're actually dealing with in this step. So it has totally found the right spot. Yeah, regarding the different object sizes in the image, we have the low resolution and the high resolution stage. And in the low resolution stage, we get these rectangles. And we could say we don't care how big the rectangle is, we just look at the center. We take the center point, and then we pass on this center point to the next level, and again construct a rectangle around it, and then scan this area, like wiggle it around a little bit until we find the best match. That way we can basically do all the object sizes at once. And because on this coarse level, all you need to find is the center spot of the actual object, no matter how big you assume it is. Because we have to do the recognition process multiple times for each assumed size of the object. But we can still save a lot of time. Because often to see where an object is not that hard. Just to see which object it is exactly is the hard part. So let's say we have different sizes. Assume proto sizes. Let's get the width of the image first. Yeah, let's make that a convenience function too. Get width. There. And then we have a list of sizes. Say we assume, let's do something ridiculous that we will improve later. The actual idea would be to go in a logarithmic procession here. We could do that too, actually. Earlier I did it like this. 70% of the image height in this case. Then I divide by square root of 2. I divide again by square root of 2. So now I have half the original size. We need to go through some different sizes that the object could have, while not doing too many steps and not too few steps. This is not really the worst way of doing it. Let's make a function out of that. Yeah, square root of 2 progression, I guess. Yep. Int. This is clearly math. Start value. And how long are we? How many steps do we make? Yep. We include the actual start value. Downwards. Divide by square root of 2. Repeatedly. Oh, and we need to round. Yep. Yeah, that's pretty elegant. And we start with more or less a full image, but we don't have much to scan there. Maybe we'll actually go square root of 2 once. And let's say we do 5 steps. Not the most elegant naming, but who cares? Let's print those. Okay, one more, and no. Yeah, that's pretty cool. Out of a base image of 720 pixels? No. Wait, what is our base width? What? 640. Yes, 1280, 640. Okay. Yeah, it's the resolution we get from Vector. Okay, these are 5 different assumed sizes in the image. This image we are using here is going to be not going to be the smallest one. Maybe in the middle or here. And maybe we need more steps. Maybe square root of 2 is too big a change. It might depend even on the image we are looking for. Anyways. We do a scan for each of the prototype sizes. Which we have to scale. No, what do we have to scale here? This is the input image width. Yeah. Scale double. Let's make that. I usually use double ratio here, which catches divide by 0 exceptions. It's so stupid when you have it. Yeah. In some cases, you just want to ignore exceptions like this. You should probably not ignore that, but it's usually nice not to have an exception. If deep in your code, you just divide by 0 sometimes. It might not even matter because it's just some little part of the recognition. So just catch the exception, and it returns a null. If you divide by 0. If you divide by 0, this function will just return 0, just to return something. Okay. I round, whatever. Scale double, I round. We scale from the original image width. No, from this one. Yes. I believe this is what we do. There's lots of numbers to juggle. All the different resolutions and then a value inside of that resolution. Multiply here, divide there, and you are done. Prepare for errors. And there we go. Errors. So we scaled the prototype image to 11 pixels wide, 8 pixels wide, 6 pixels wide. All in this 16 pixel wide image. Okay. And we do get different candidates. Fair enough. And now we want to pick the highest scoring ones. We should a little gravitate towards bigger results. Because if you compare a small image, there's just less capability of error. A good match in a bigger image is worth more, basically. But I think we are going to ignore this for now. Yeah, all candidates. All candidates for all proto sizes in whatever, in course image. Yeah, we do need the scores here. Let's put the scores back in. Failed. Do not fail on me. Okay, I failed. What's the time here? Yeah, why not? 1 hour 18. I believe this is something important. The thing I built here. Uniquify. If the same size comes up twice, we only want to process it once. That also means we will not get identical rectangles ever. So we can just use a list here. And we can sort those. Where did we do that? We did that here. Sort by second of pairs. Candidates. Now we should have the best candidates for the next resolution. And we need the scores here too. Here we forget the scores, finally. Mm-hmm. I think it's a good candidate, actually. Let's show these. Wait, how does that work? Candidates. Scale rects. I'm sure we don't have it. Yes, we do have it. Huh. Wow. Swap scale rects. That was some AI assisted coding right there. Oh. See, the second function was just made by my AI by reversing the parameters of the first one. Always a nice feeling when a computer helps you code. What is the problem here? Oh. This is the problem. Okay. Oh, we were in the 16 pixel resolution. Still nothing. No, they are already scaled up, I think. What's happening there? Oh, we are getting the scaled up results. Yep. It doesn't matter, we can scale up and down again. Okay, sure. So this gets a lot easier here. Candidates are in full image resolution. Finally, some results. Okay. Coarse resolution to work on. Any other 16s? No, that was all, I think. Look for candidate. Look for center object candidates. Center object candidates in coarse resolution. Centers. Center of rects. Yep. Nope. Center of rect. Centers of rects. Center of rect, whatever. Another bog standard little helper function. My AI will totally pick up these patterns and program for me at some point. Now we have some center points. Or not. Now we do. Yes. So these we pass on to the next stage. Stage 2. Scan around candidates in higher resolution. Oh, didn't mean to start. Fine resolution. Okay. Let's go to the full scan again and turn it into a partial scan. We only want to scan around these candidate points. So full scan. Basically, we just call this function, but we want to calculate the similarity, not the difference. Okay. Return similarity, not difference. Yeah. Acceptable. Yeah, and once again, we want to find the n best results. There's a function called pixel spiral, which makes a spiral-like pattern around a point as big as you want it. And we're going to use that for scanning the area around these candidate points. Spiral, it's an iterator. We have to decide on how big we make the spiral, which is another open question. Let's do it in this test window first. We want to remember which points we tried already, because we might get them multiple times in different spirals. So set of point. Tried, points tried. Yep, spiral size. Did something that was generous, I think. We divide the high resolution by the low resolution, take it times 2, and that's the side length of our spiral. I think the real choice might be between this and this. But I was being conservative here. In the end, we will have not two stages, but probably go from 16 to 32, wiggle a little bit, take those candidates, go one higher and one higher. It will probably save a lot of search time. But right now, two stages are, I think, complicated enough. Pixel spiral. Takes a few arguments. Yeah, exactly. It takes the point where we start, which we have to convert. P scaled, scale point. First of all, we can scale them down beforehand. Candidates. Okay, yeah. Scale candidates to higher resolution. Oh no, this was actually nonsense. I thought we have to check for duplicates. But if we scale something from a low to a high resolution and the points were unique before, they will be unique afterwards. So we don't have to do that, but we can do it here. Double ratio. Now we have the scaled center point. We go around this point. We give it the image size. Yeah, there's a bit more optimization to be done here. Doesn't matter. Int ratio. Do we have that? Show. No. Yeah, scale double I round. That's the one I wanted. Sometimes remembering the name of a function is the hardest part. Okay, I wanted, yes, from to, from this to this. What? I'm so confused. No, I want to get the height. Okay. Yeah, finally. Just trying to find out the height of a scaled down image. Oh, but I don't really need to do that. I can use a scaled input image. Yes. Yeah, that's much better. Scaled input image. Get the height of that. Whew. And pixels per spiral. Now we have all the points in the spiral, and we try those. Can use the cooler function here that does this conversion from error to similarity. Yeah, that's much cooler. Yeah. Right. Yeah, single check, that's what we want. Single check. Back.single check. Yeah, I miss my autocomplete here. This has no autocomplete, this particular window. I should change it to some smarter text area class. I have one, but I have to integrate it. It's yet more effort. Scaled input image. Scaled proto. Oh yeah, we have to do that thing again. Go through all the scale sizes. That's some fun. We could save, yeah, some time by noting how big the image was that we found in the course step. But yeah, still some things to experiment with. Here, scale proto. No PW. Lots of variables too. Scale proto, then we have this other point. P2.x, P2.y. Min similarity is, as always, completely unknown. Probably more than 0 though. Well, it depends on the lighting and stuff. So, okay. Single check. And we basically save the result just like before. And this time we might just look for one best result. Right. There's only one cube for at this point. Yeah, finding 2 cubes in one image is also possible. Everything's possible. Just right now I don't do that. Yeah, actually just put it in our collector for results. Foo! Scaled proto is undefined. Oh, it's called scaled prototype. Or not. Oh, we need the prototype, yeah. Proto.scale prototype. Okay. I'm lazy, I only add methods on demand. I can't even concentrate anymore. I make the method when I need it, not in advance usually, which saves some time. Oh, what do we have? We have nothing. Why do we have nothing? Points tried is, oh yeah, wait. This now belongs. Yeah, there are 1 or 2 remaining problems. Points tried. Okay, we have 3 loops in the end. We go through the candidates, through the scalings, and through the spirals. So, if we take this here up there, okay, like this. We go through the scale. Then we go, because here we can keep the list of points we already tried. which saves us from some double effort. Maybe it doesn't even matter. Yeah, it should, I think. Okay, continue. If it was already tried. Continue. And the points are not quite right. Move to top left of prototype. Yeah, okay, whatever. Translate point. Now this is the center of our spiral. And yeah. Let's print what we're trying. Which points we're trying. Trying point P2. Yes. Another lazily added method. Translate point. Das kriegen wir doch hin, as the German says. That's something we can do. That we can do. And we did. Das kriegen wir doch hin. Das wäre doch gelacht. So in essence, we are trying 0 points, it seems. Centers, it's all good there. Let's print another variable. These are the width of the prototype to try, that's good. Something wrong with the spiral is not spiraling. Oh, it is, yeah, okay. Scaled center point, but oh yeah, it's way out of the screen range. Something went wrong here. Oh, the center points were actually in the original image space. And it should be like, I keep making these pointless windows. Yes, we scale from the input image space to the scaled down space. Exactly. Now we have something, and I think it's correct, it's just not displayed correctly. In fact, if there's any result at all, we scale up. No, let's scale up later, every millisecond, every nanosecond, that we can save counts. Best in input space. Scale. No, we have points actually. No, we do not. We have rectangles. I used to have this function here. I do have this function here. Scale to input image. Yeah, let's do it manually, whatever. Oof. Oh, and show the correct one. Let's clean some of these old windows. Well. It was a bit of a hard image because I said in the beginning we assume the image we search for is completely in view, just for simplifying stuff. Here, 891, let's try this one. Yep, here. Oh, let's print a little less. Well, isn't that cool? Recognition time 435, but that may improve. Now we could make a live recognition, right? Am I proud? Maybe. Okay, let's turn this into just a module right now. Why not? That might end the stream too. Because you get this jelly-like feeling in the brain after concentrating, programming, and streaming for some time. Something happens to the neurons. Okay, vector live recog spike 1. It shows its own image. Yeah. Set select, yeah, no, it's set image. Input image. And selection. Start. We do it in the module queue. We should take care not to overload it though. If it's slower than the image feed, it should not stack things up or something. Yeah. And when there's a new image from Vector, we analyze it. Have a vector image. We even forget the image. We are getting it again here anyway. So this is all a lot simpler. I have vector image. Yeah, this should be good. Okay. This should all work unchanged, yes. Huh. 0 FPS because when Vector sleeps, it stops sending camera images. This is the image still from when it went to sleep. True. Huh. Oh. Nope. What did I do? Wrong type is what I do. What I did. This is correct. Wow, let's see. Okay, it has the problem I mentioned before. Yeah, let's wake up Vector and see what happens to this window. Drum roll. Hey, Vector! Wake up! No, just there. Stay there. Okay, this is not as cool as I thought it might be. What's happening? Also, I mean, it's fast. I want it to be fast, but is this okay, really? Does it do the right stuff? What was the prototype image? What is the prototype image? Prototype image is this one. So like, which one is it? Which one of these? Like that? No, it's a different side. Here, I guess. Like this? I think. Okay. And this result kind of makes no sense. I don't think that's actually correct. What's happening here? Let's copy this to clipboard. Let's upload, in fact. Cube test 2. And let's analyze. And yeah, let's make this one disabled. There. What do we have? Number 4. 894. In fact, it does give this result. How is that possible? That's weird. Oh, vector is active. Oh, more FPS. It depends on the brightness, maybe? Who knows? Let's use a different prototype and the actual input image we are concerned with right now. Okay, it's doing stuff. Oh yeah, it's doing the recognition 1000 times. That was a bit lame. How about once? This probably doesn't use the right sizes. What if we take more candidates? Oh, this one has a fixed size, I guess. Does it? Let's see. Oh yeah, okay. Switchable. %? Huh. Aha. We are getting size 0 here. That can be fixed, I'm sure. What's happening with my computer? It feels sluggish. Oh, just an illusion, I think. Okay. Maximum of 1 or minimum of 1 should do it. If the resolution is very small, like we do 1 pixel here for the whole image, then the prototype it looks for has size 0, and then it fails. Okay, this is cool. It takes me for the cube. I mean, that's not what I wanted to see. In fact, it's funny, but it's not what I wanted. Yeah, there's different things we didn't do yet. One, we didn't correct the lighting, which might be a factor. And 2, we don't account for rotation. What if we show more candidates? I mean, shouldn't the real cube pop up at some point? This can't be right. 100? No. That's weird. What's the prototype? This is the prototype image. Let's make the size a little bigger. Try again. Still the same shite. Oh, here. So I was really, really sure that I am the cube. Is that some sort of bug? What's going on? What is going on? It should at least work sometimes. I really don't get this. This has to work sometimes. Okay, it needs further investigation. Let's upload another image. Cube test 3. And now I'm really a bit tired. We'll continue soon.